Coming to our little event with such a wonderful mindset and spirit, which I just assume that you have. We all gathered here, the 6 speakers, Linn and I and my colleagues, and we are so happy to have you joining us in our first eBazaar, something we invented about a week ago. We said, what can we do in these days to help our members, these small, sharp, hardworking, entrepreneurial driven companies? And we agree that the only thing we can do is to really try to help fill up the sales funnel from those companies. So when the light is back in the funnel, they will also have a lot of prospects to continue to work on. So my name is Magnus. I'm one of the co-founders of Things, and together with Linda, actually, Linn, who also is here. And Things, this is the deep tech hub that we started 6 years ago. We just celebrated our 5th anniversary, and we are only doing one thing. We try to learn together how to transform innovation in small, clever, sharp companies to value creation in large companies. And we do that by collaboration between small and large companies. We have currently 120 members among the smaller ones and 45 corporates among the bigger ones. So without any other talking about that, I just wanted to give you a couple of ideas how to deal with this little event. First of all, I will moderate the event as well as I can. We have a technical host and a host who keep an eye on everything. We take all questions for the audience over chat, which you will find in the bottom right kind of part of the bar. And I want you to post your chats to all so people can see them and so forth. If the speakers leave time for questions, I will try to raise the questions to them and nothing else. Secondly, we filmed the entire event and we will use parts of it or the entire film in our social channels. So we would like you to be taking away your videos, really. That's the best way of doing it, in order to not blur the movies with too many kind of nice video pics. And you stop the video down in the left corner. We also want you to be on mute. That's quite important. I will try to keep time very, very, very hard. And afterwards, we will send a post-event mail to all attendees, where you will see the contact details to all our speakers today and some other information, and probably will ask you about feedback if we dare. So without any other ado, let's move on to the first speaker. So I would like to welcome Olov Hisved from our member company, Cargo Beacon. Olov, share your screen, please. Oh, sorry.
So can you hear me?
Yeah, oh, there we go. Olov?
Yep.
Can you share your screen, please? There you go. Excellent.
All right. So my name is Olov Hisved. I am the co-founder and CEO of Cargo Beacon. About 20 years ago, I was doing my master thesis, and I started working at Access Communications. By then, we made a product called BAP, Bluetooth Access Points. Today, we know how it went for Bluetooth access points, but today, 20 years later, I'm mounting such things again. So with the help of little tags that we can attach to goods, we digitize value chains. We put positions onto different types of items for manufacturing industries. And that's what I'm going to present for you. So, if it works. So basically, we have a platform where we have combined a set of different products. We started off doing a data logger used in logistics, focusing on historic data, storing temperature, humidity, and shocks used for niche applications in logistics. High-value goods, for instance, sensitive goods, and so forth. Developing this, we realized everyone in logistics, they want to know where is our goods currently, real-time information, and where is it, not just how has it been treated. So what we've done is that we've integrated features to emulate a GPS tracker. So with our smartphone app, for instance, running in the background. We can attach beacons and tags to goods in logistics, especially larger items, bulky items, and with the app installed for drivers and people working in distribution or maybe in yard management, they can track where things and possessions are, assets are for companies. And this is a very scalable thing to emulate, scalable way to emulate a GPS tracker. And the past 2 years, I would say, we have partnered with another company who have developed a standard for doing RTLS with Bluetooth-based beacons. And RTLS stands for Real-Time Location Services. It means that you can accurately track things indoors. So this means we can provide tags at low at cost with battery life for years that you can locate accurately outdoors as well as indoors. And we try to squeeze down, we try to include as much value as possible in this offering and provide it at a scalable, at scale, so that you can track lots of items, basically. So our unique selling proposition today is that we digitize value chains for better productivity, for better safety and improvements for manufacturing industries. And let me exemplify this one at a time, how this can be done, from how manufacturing industries can take use of these systems. So for instance, ways to achieve higher productivity with RTLS systems is that you can tag finished goods or work in progress material and know exactly where it is. You never have to look for it again. And of course, load carriers such as pallets, fixtures, or roller cages. And you can avoid disturbances by making sure you never run out of them ever again. So, and there's many other ways to achieve a higher productivity with this technology. We also see a lot of possibilities around safety. Since we have an indoor map and a positioning engine running as a backend server, we can communicate with tags. Tags can be a wristband like this, which is BLE enabled. And this means we can, in a production floor, we can mark different zones where it's okay to go. But if for instance, a visitor has a wristband like this one, we could make the wristband beep or alarm if the visitor crosses, if the visitor would cross a painted yellow line in the floor. I'm a bit, yeah. Of course, you should also tag forklift trucks. That way you can understand the utilization rate of these forklift trucks, and you can gain a lot of good insights around them. But working with safety, you could also define safety areas around these moving objects and people. And if a forklift truck is approaching people, this could be visitors, this could be your employees. We can once again, from the back end, send signals to the tags. In the forklift, we could, for instance, blink a light emitting diode, telling the forklift driver that, okay, someone is near. And once again, we could make a wristband or maybe a safety vest start blinking for visitors. So these are two examples of how you can work with passive safety with these systems. From my experience, one of the biggest problems in the manufacturing industry for electronics has been to build engagement around continuous improvements and introducing changes into operations. And I would say this is the tool to measure what current status is, as is status, so to say. And when you do changes, you directly can visualize how it affects operations, and you can build engagement among your employees in these changes. So for instance, let's say electronics manufacturing industry, you could tag picking bins whenever people go out and they pick different items for assembly, you could track this picking bin, and you could visualize it in a spaghetti diagram. For high volume products, you would optimize the route, so the picking route becomes shorter. We also have a lot of discussions with, especially in the electronics industry, with customers that are interested in understanding the time it takes for assembly. And then you could use, for instance, have a bucket of tags and let personnel pick a unpersonalized tag, a unique ID, at the start of his shift. And while starting working, you would follow and see for how long does he stand on a certain spot. And you can visualize this in different colors as a heat map. And this way you could understand, does it take a long, what does ERP system say? Does the assembly process take as long as the ERP system says? If it doesn't, maybe you should change the product price. So this is another example of continuous improvements and how you can work with this. A lot of requests we get that's around as-is analysis, and these are the visualizations you usually work with. So if you want to do investments for like AGVs or something like that, you want to understand current status, and then you often want to trace a spaghetti diagram or something similar. So just to provide you a little bit of what it could look like. I do the risky thing always, an online demo. So this is our office. This is me in office 2. And we got an entrance there. I assume you could see my camera still. So I got a tag here. I push it, you directly see that it indicates on the map. And I take this tag and I walk outside. But I'm not leaving you guys, I'm back. And I brought another tag as well. So that's like a demo of what it works like. And this is the presentation I usually have to start a discussion with customers. That's all about, that's all I was about to say for now. So, thanks.
Very good, Olov. Thank you so much. And I haven't received any questions yet, so I will ask you a question myself. So where are you commercially at this point? Do you have reference customers, or are you up and running?
Proof of concepts. So we have lots of proof of concepts and lots of discussions. And we are also looking into, we believe that for this market, we need to provide a nicer entry point maybe, because what we do with this technology is that we could, depending on your upfront investment cost, we could roughly position these devices as well, just using smartphones or low-cost access points, so to say. So we are adapting our business offer and building it and building customer references for now. So, and this is a very new technology as well. So I think it'll take a year or two to settle, but we see it as a perfect technology for SMEs.
Can you give us some kind of hints on cost for tags or systems in an application like?
Yeah, I think cost for these types of tags could be 10 euros in volume. And for the system, when we talk a system, we call this offer precise location. We also have proximity location. But with the precise location, we usually need one access point on roughly 500 square meters. If it's like 8 meters in roof height, the higher up to the roof, the better it is, basically. And that would be around 10,000 kronor for one access point, basically. Yeah. Questions? I don't know, maybe there are questions. I don't see any. I see a chat window here.
Yes, you're muted. I think you're talking.
How will your system compare with 5G positioning technologies?
Oh, 5G. Oh, thanks. Can you still hear me? Someone said I'm muted.
No, I'm but.
All right. I would say we have to make a difference on technologies that are used for different applications. This is an application of asset tracking, finding objects. 5G, I would say that's a perfect application for wayfinding. You would have 5G in this one, and you would find your way in a shopping mall or that kind of things. Because 5G, you would get a big modem, you would get some large batteries, you don't get the scale benefits.
Okay, great. And there's another question which is kind of related, which is how do you do tracking outdoors?
Yeah, so that's we got a couple of different approaches there. First off, we got these typically those similar hardware that is used for fleet management systems, so that you do rough, usually when you're outdoors, we are looking for large objects. So it's not really, you don't need the 2 decimeter precision. And then we either use computers in vehicles to scan for tags, or we can provide attachment hardware for these vehicles that can scan for the tags and attach a position for where this gateway is basically. And you know the tags are within 10 to 30 meters, which is usually enough in logistics and outdoors. And of course, we also have the app for smartphones.
Great. Here's another question. There's somebody who came a little bit late, so we have to apologize. What is the underlying connectivity technology for indoor positioning?
So this use what has been defined in Bluetooth 5.1 AOA, angle of arrival. Basically, it means the access point has got a lot of antennas and it's able to find direction for the tags. And with a like a map coordinate system, it can calculate. When we have 5 access points in our office, you can calculate quite accurately where it is on the map by combining information from different access points.
Brilliant. I think we have to stop there now, Olov, because we have a lot to do. Thank you so much. I can hear the virtual applaud in cyberspace somewhere. And like with all sales calls, you know, I hope there will be a lot of follow-ups very soon. So with that, thank you. Please share your screen, because I will ask somebody to
just a second. I figured as we have a couple of late arrivals, perhaps my industry would just do a quick run through of who will be presenting and in what order.
Okay. So let me just, here we go. So yeah, after Olov from Cargo Beacon, we'll have Niclas Krantz from MTEK. We have Daniel Spahr from Analyze, Gustav Lagercrantz from Gemit, and Pär Bergsten from H&D Wireless, and finally Linn Sidahl from Ekkono. And each of them have about 10 minutes plus 5 minutes for questions and answers. And we will give you the contact details for all these people in the post-event mail that we're going to send you attendees. So with that, I would like to introduce our next speaker. It's Niclas from MTEK. Actually, a neighbor, not Niclas, but the company is neighbor to Olov's company.
Yes, we are. Can you hear me?
Yes.
Very good. Hi, everyone. My name is Niclas Krantz. I'm heading up sales at MTEK. We are a software company making manufacturing simple. So what if you could cut your yield loss in manufacturing by 50%, your lead times by 90%, and be able to personalize your product supply? What if you could automate the flow, allowing your staff to focus on better things and improve work environment for them? What if you could get real-time visibility on the performance of your product supply? Well, you can. At MTEK, we changed the world of manufacturing through digitalization and automation. We enable better products, production, and processes. We enable our clients to be data-driven. How do we do it? Or sorry, first, let's see how the manufacturing world looks like. These are the challenges that our customers are facing. We see an increased demand of faster product development and time to market, which will put demands on their production abilities and the flexibility in their production environment. We see changing end user preferences towards a high mix and a high volume scenario, meaning a massive opportunity for mastering digitalization and adaptive automation. We also see a high employee turnover, aging population, challenges in attracting and retaining manufacturing operators, and also a global increasing labor cost, putting strains on the employee side. In addition, we see that many manufacturers have a limited insight into causes for their production inefficiencies and the faults that is happening in the production, which increases the cost and lowers the quality. So how do we help them then with at MTEK? So MBrain is our manufacturing intelligence system. With it, you can digitalize and virtualize the manufacturing flow to optimize lead times, inventory turnover, and delivery precision. Using statistical process control and AI and ML tools, we can support your continuous quality improvements in your manufacturing. MBot allows retrofit of intelligence into your existing industrial robots to make old, stupid robots actually talk. We connect it to MBrain to understand the machine's behavior, improve the conformity to quality requirements, and increase the OEE. And MCell is our adaptive automation solution, uniting technology, methodology, and know-how into a scalable and very cost-efficient and modular cell for automation. It reduces time to market for new use case development and new products through a software-defined robotic solution. I will now go through each of these in more detail. So MBrain is the factory intelligence system. It allows you to digitalize and virtualize the production flow across all of your workstations, across all of your factories and your enterprise. It helps you improve the quality, the time, and the cost of your manufacturing. With it, you can collect manufacturing data from basically any machine and any process. You apply analytics to it and you act on the insights across these processes in real time. You will be preemptive with advanced technologies like machine learning and artificial intelligence. We allow you to facilitate the production line design, including documentation for different processes and machines, and allow you to drag and drop AI down to a machine or a process, and basically analyze any given parameter of your production to improve your quality or understand where inefficiencies are. We provide full provenance of components, products, and production sequences across the complete flow, which enables for quality checks, traceability of components, and also a reduced cost for product callbacks and claims. So that's MBrain. MBot Connect, today we are launching this name. Let's see how it sticks. It uses our proprietary software, which we call MLib, to enable, as I mentioned before, a retrofit of intelligence on industrial robots. So the combination of MBrain, which I spoke about before, and MLib allows you to visualize all machine data and allows your users to understand which errors are causing faults in your industrial automation. You can here also apply statistical process control and machine learning to predict faults and create actions and even prevent actions from happening in your old robot. With it, you can also understand the machine behavior, not only the machine's behavior, but also the robot application in the machine on an individual level to increase the machine's performance and improve the OEE. When you do the monitoring of data over time, you will also be able to see different drifts or anomalies, and allowing for predictive maintenance of your machines, which is not possible today in the same way. MCell is our adaptive and automation solution for high mix and high volume assembly. It gives you a high precision and a very digitalized flow. So the cells that we build, they are very modular. They are uniform and modular. It's a very simple hardware setup to secure that we have a low cost in the overall equipment. It's easy to integrate and adapt to the changing customer requirements. The whole cell is software defined. So the software is initiating and calibrating robot. It does the assembly, it does the performance management, and also with our software, you can do the auto programming and the auto sequencing of the robot just by dragging and dropping a CAD file and make it very simple to reuse. We can do these deployments in a matter of weeks, and we can do changeovers between different products down to minutes. You can change and develop new use cases with the software. And you only need to design new feeders, grippers, and fixtures, and you're up and running in no time. So I'm going to talk about a case where we're combining all of these 3 solutions that we bring to market. It's an odd form placement case from one of the world's leading EMS suppliers. They have a large industrial customer base with a very medium to high mixed scenario, medium to high volumes. So the project was to pick and place 12 of these components, which you see on the picture, and place them on 34 different positions onto a PCB board. The cycle times were not to exceed 5 seconds per component, which might sound long, but an operator does this in around 6 to 7 seconds per component. And actually in our acceptance test, we were down to 4.2 seconds. So we do it better than the operators in this case. We were to integrate the cell into an existing conveyor belt, and we had to use their existing ABB Yumi robot for the deployment. It should be easy to redeploy for new use cases, as they have a lot of high mix scenarios going on. And they didn't want any new project or any reprogramming to happen. And we were to do this in 14 weeks and deploy it on site in Eastern Europe. So the pictures is not from the client, just to be very clear. So some of the challenges when you do a project like this is the high variability in all of the environment, in all of the components and material that you use. There's a variation in the PCB boards. There are variations in the components. There are variations in the pallets. Variation in where the PCB is actually located in the pallet. And there's variation where on the conveyor the pallet is located. So due to this, we need to have a very high absolute accuracy, 0.1, 0.2 millimeters accuracy to actually place a component within the holes. And this is not to be mixed with repeatability. So we actually need to, every time a new pallet comes in or a new PCB comes in, we need to readjust the whole space for the robot. Further, the flexibility that this customer, requirements that the customer had, was that we should be able to actually pull out the robot, put in a new robot to do a different assembly there. So you always have to adapt to the changing scenarios. And then the reusability aspects to deploy new use cases without any programming. Puts quite a big challenge to us. And this is solved with the mBrain, with mLib and mbot and mSol. So the video I'm going to show you now is not from the customer either, but it's a reference case that I will talk through. Hope you can see it. So here on the conveyor, the robot initiates the pallet. It drags it into the position. It stops. It reads the QR code to understand what product is it I should assemble and what is the idea of that. It starts to pick the components from the feeders in the bottom of the screen and place it on the correct position. If it should be so that one of the components does not fit into a hole, it will actually try to find with a specific pattern for where the holes are. And then it will update the whole space to understand how it should place these components in the future. So if you want to change your manufacturing through digitalization and automation, if you want to have better products, production and processes, and if you want to be data-driven, please connect. My contact details are below. And let's open up for questions.
Excellent, Niclas. So please give me your question. Niclas?
Sorry, I cannot hear. Sorry.
Yeah, Niclas. Do you have any customers that you can refer to in public with names, or are
no,
they still?
I will not do that.
Okay, I have a question now for you. Any examples of drag and drop AI?
Sorry, Magnus, I cannot hear your question. Can you write the question?
Yeah, I can. Sure. Any examples of drag and drop AI? Don't you hear me?
I don't hear you, Magnus.
Okay,
sorry, you break up.
Okay. You see my question now?
Hold on. An example of drag and drop AI. Yeah, so what we do is that we virtualize basically your production. So we connect to any machine or any process in your manufacturing site. So you have all of the machines on a virtual flow. On that flow, we can drag and drop AI into your machine basically, and start extracting the data and start learning different patterns from the data that is coming from your machine. Based on that, we build ML routines to actually know when things will happen in the future, basically. So that is what we mean by drag and drop AI. So we drag and drop it in our virtual environment.
Okay. Any more questions?
For recognition, you use RFID. I don't know if that was for me or for tracking beacon.
Yeah, it's for recognition. That's for you as well.
Yeah. So for recognition in the RoboCell, yes, we can use RFID. That's correct.
Do you see the question? Do you use camera? Yeah. Okay.
So the camera for locating the parts in the video example. Yes, we use yes and no. We use cameras to locate the pallet and the components in the feeders. But we also use the UMI to actually touch and feel in the space to actually understand how we should pick the components. And some of the feeders also have location or QR codes on them, so we actually know which component there is. But yes, we use video, the camera in the UMI.
There is a second question for you.
Yes, I saw that. Yeah. So today we approach customers on our own as MTEK, but we are very happy to discuss any different partnerships. So if you would like to discuss that, please reach out.
Great. Any more questions, or we say goodbye and thank you to Niclas?
Goodbye.
We say thank you and goodbye to
please
Niclas. Thank you so much. Please unshare your screen.
I will.
Okay. Great. So to our next speaker, it's Daniel Spahr from Stream Analyze. It's a company also based north of Stockholm, but this is much closer to Stockholm because it's in Uppsala.
Yes.
Are you
Can
ready?
Hear me loud and clear?
You,
you should be hearing me loud and clear, I believe.
Yes, and I see your slides, so please take it away.
All right. Hello, everybody. My name is Daniel Spahr. I'm COO for Stream Analyze. We are a software company. We build a small software platform that allows you to build, run, and deploy AI models onto any hardware device out there, allowing you to analyze data as it's being generated. I'll get back to the details on this shortly. Starting off with a few use cases just to sort of whet your appetite. This is Volvo construction equipment. What they did is they create these or build these big wheel loaders used in the mines. That's a heavy duty environment, and these things break down frequently. They were trying to actually build their own predictive maintenance system onto the machine itself, because connectivity and working with streaming data up into the cloud, which is normally what you see in IoT these days, just wouldn't work from down in the mine. The problem they had is the turnaround cycle for developing this was just way too long, because the engineer had to book a test driver, record the data of all the sensors that was on the machine, analyze the data, build a model, pass this on to IT, you had to develop it, implement it onto the hardware, retest it, etc. It took them about 2 years to actually get it onto the machine. So what we did is we could install our software platform, allowing the engineer himself to build and deploy the models that he wanted to create interactively. And this sped up the whole development cycle immensely. And we could predict 10 to 12 hours in advance when a gearbox was about to break down. So the driver could then try and get the machine above ground and meet up with a technician in due time, improving the productivity of the mine. Another use case, we presented the things before together with HMS, and it's HMS Networks. They are really good at connecting factories and machines in factories for manufacturing. They create these small devices you see on the picture. They're routers and gateways. managing data between machines. You buy a machine from ABB, you buy it from Siemens, it might be difficult to have them talk to each other. HMS's solution does this. However, thanks to Industry 4.0, their customers were looking for AI to their machines, understanding, okay, when are they breaking down? How can we monitor them better? And they found us, we found them. We're being rolled out on top of their platform now, allowing their customers to be able to build their own AI models close to their machines, and now being able to monitor them in a timely fashion. There's a couple things that we do. So what do we really do? We have a small edge analytics platform, and it brings any AI model out there onto any of your existing and future hardware. And it requires really no need for deep programming skills, but rather made for engineers and analysts, because we believe we want to leverage the people who really understand how your machines actually work. And it also has the feature, allows you to interactively query the machines, but also deploy these models interactively on the fly, speeding up your development time, but also making things more interactive with what you have out there. And how does this look like? Looks like we have a small software platform. It's called SA Engine. Essentially what you do is you install this platform onto your device, if it's ball bearings or if it's chainsaw or if it's a wheel loader. And we also have an instance that you install into your cloud. Now these two connect with each other, and now from the cloud you can build, deploy, and run. You actually build and deploy the model onto the actual device, and then from there you can run your model. These can be models for monitoring the machine, it can be for predicting if something's about to break down, or it can be for automation, adding new services and features to the machine interactively. And for this also allows you, and for this case, you can see in that we had a monitoring center actually together with Volvo. So when an alarm was generated, the monitoring center could then drill down and ask what's actually happening on the machine. But the technician also, before being deployed, could start drilling down and understanding what's happening on the machine, making sure it has the right tools and the right spare parts, for instance. And this interactiveness makes it very, very powerful, I believe. Finally, this is one thing that we believe that we want to sort of push forward. Working with deploying AI models onto hardware device in the edge, it usually follows that top cycle where you have to collect a lot of data, sort of like we did with the Volvo case. And recording that data might be cumbersome, and also doing the analysis. But then you have to actually build this and deploy it onto the hardware and refine this and iterate across this. And it can take years, like it did with Volvo. However, what we see that we could do with our modeling is, and we can show this in demos for you if you want to see, is that you can actually build these models and evaluate them, refine them within minutes. So the interactiveness really speeds up your development cycle for AI onto the edge. And why is this important? Well, see, we see that most of the time that you spend actually developing AI or analytical models on edge devices is spent in seeing and understanding your data. Because if you don't understand your data, you don't understand what you need to build. Often it's a misconception that if we can deploy AI onto our hardware, then we've sort of fulfilled the Industry 4.0 device. But see, you need a tool that allows you to see your data, understand your data, to then build a good model to be able to get what many people really dream about, and what the industry is talking about is automation. And that's, and our platform supports that whole development cycle, really, allowing to do all of these things and not just one. So what makes us unique? And there's 6 things that we usually sort of want to push for. One is size. And why is that important? Because we don't believe in having to bring new hardware device onto machines. And these can be very, very small CPU devices, all the way down to 100K we can fit onto there. And then adding to that the model onto this. And our largest and full-fledged version, we're at 5.2 meg, which is normally enough in most of the cases that we're working with. And this means that you can go on to anything that really out there, really close down to small, MCUs, or even onto sensors if they have enough memory. The other thing is the online edge analytics. We mentioned this. Our platform allows you to work interactively with running and deploying models, but also being able to query your machines once you have our platform installed on there. And we sometimes jokingly, take up the example of Tesla, who often, boasts with being able to update their cars overnight. We can do the same. The third and fourth one go hand in hand. I mentioned this a little bit. We want to empower the analyst or even the engineer. And a good case that we had was with Husqvarna, where we had one engineer really understood chainsaws. And he, using our tool, could now create his own model and interactively work with it on the chainsaw, speeding up his whole development cycle by a magnitude, having worked with it for 5 or 6 years. Now in 6 weeks actually can get this up and running. So that really empowers them to do this, but also being able to know that they know best how this should work. We don't require any additional hardware normally because we believe that you can use what you have today, and that because you don't want to have to retrofit, because that just sort of throws your whole production out the drain, and you can use what you actually have because we're so small. And then finally, of course, we give machines a brain. That's sort of our whole thing. But because we are a generic platform, it allows you to use any kind of mathematical statistical model to machine learning, any machine learning model or neural network model or deep learning model that you like. And we're fully compatible with all that. It's sort of like you get Excel and you open it up. If you're a CFO or if you're a controller, you'll use different models. You know how to do this. This is what we can do. We're a generic platform for that. Finally, just to see, okay, how can you actually use this then? Well, one thing is customer insights. By deploying our platform, it allows you now to understand how your machines are being used, or how your customers are using your machines and how they're performing in real time. That gives you clear customer insights, and that goes back to understanding your data and what's happening with your tools or your machines. Then you can optimize and improve your processes or how they're being used on the fly, because all data is being managed locally on the machine rather than being pushed up into the cloud. And this really helps things out in terms of improving your process, and then finally being able to predict and add new services and even automate your products over time. And this creates a full life cycle, we believe, of creating new services for your products over time. And that's pretty much all I was going to present now. And if you really want to have a live demo, feel free to reach out to me afterwards, and we're happy to book this. And now during Corona times, we can obviously do this online as well. I'm right under 10 minutes, I think, Magnus.
9:22, brilliant. So do we have any questions for Daniel? I have one, which actually came already throughout your presentation. So where are you in the commercialization of your technologies and products?
Well, our technology is fully commercial. It's not slideware. It's up and running. We're running a few POCs today with some fairly big customers. HMS is one of them, and we're rolling out on their platform as we speak. And so that's what we're doing. We're developing some products or some projects to push it towards commercialization.
Right. No questions from the audience?
Clear as mud, I guess.
Yes, I have a question here.
Go for it.
Hi, Daniel. My name is Bo. And
hi, Bo.
I'm wondering your system and solution could be only apply for the heavy duty, or you can also deploy for traffic, like public safety for buses and the train.
Sure.
And even for the electricity.
Yeah, there's actually there's three industries that we've targeted primarily, but we're not restrained to those only. But the three ones that we see is one is manufacturing or industry in general. They've been working with sensors for years, but not having the full internet capabilities of it and the processing power that we can do now today. They're very mature for that. The example of manufacturing. The second one is automotive, which I think I've exemplified as well. They're also expanding on the number of sensors you have in each car, and I think Volkswagen is a good example, saying that they're going to include about 4 terabytes of data production, produce 4 terabytes of data per car per day, and that kind of stuff needs to be analyzed locally, and that can apply, of course, to buses, to trains, and so forth. And the third one is the whole utilities or energy area, and that can be used either in your assets, so monitoring assets like pylons out in the water, or a turbine to understand when it might be breaking down, or just being able to monitor it. but it could also be used we're partnering with a company who wants to analyze the final mile of the electricity grid. Now, it's an area that's very hard for the utility companies today to actually monitor. And we can do putting our AI onto their devices. We can actually recognize patterns and see when new different appliances are being connected to the grid to make sure that they can load balance their actual production.
Excellent. Thank you very much. I would like to send an email later and to ask for more about the second sections, expanding for the sensors. Thank you.
Sure.
Wonderful. Well, that's what we like to hear. If there's no more questions, we will jump to the next presentation. I think we're going to do that now.
All right. Thanks.
You again,
thanks,
Daniel.
everybody.
And please unshare your screen. And we will ask Gustav from Gemit to share his screen and get going.
Yeah, I'm sharing it. Can you all hear me?
Well, I can at least.
Great. Thanks. I'll just carry on then. Can you see me? Oh, wait. I'll just stop and turn on my video as well. Can I get my videos there? Start video. There. Hi, everyone.
Hi.
Can you all see the screen?
Yes.
Great. I'll talk about value from operational data. I'm from Gemit. We're a Stockholm-based company. We're a pure software company. We offer a service as a software as a service. To put this in context, our primarily type of customers are in the water management industry, primarily here in Sweden. We're working with the largest plants in Stockholm, Gothenburg, and throughout Sweden in managing wastewater, but also drinking water. So it's a process industry we're addressing. The one that stands out is FLIR, where we have a partnership with them, working with their thermal cameras and applying our technology in their context. Talking about what we do and where we are in this pyramid, if you have the production process at the bottom, typically you have a number of sensors, like Daniel was talking about earlier, generating data, and that's channeled up through the PLC, controlling the different valves and pump engines, etc., and in turn connected to one or multiple SCADA systems. Where we come into play is at the MES level, where it's manufacturing execution systems, where we provide our value. And I'll be talking about the different steps there and how we provide value, but to give some insight is, in some of these parts, we help our customers reach 90% efficiency gains and also optimization gains in the production process. But I'll take you through some of the steps and what we do and how we help our customers doing this. And there are essentially 4 steps, and I'll round off with some concrete numbers and examples from one of our customers. But it's taking you from data collection, getting the data from all the different types in the process, to reporting. I'll talk more about that, analytics, optimizations, and then finally automation and also machine learning. The problem with data collection is these plants are typically, they've been there for a long time. They're built up over a long time, so they have multiple vendors, they have multiple versions, and there are multiple types of equipment out there. So in essence, for them to get access to the data, they'll need to tap into so many streams of data and sensors, which is quite cumbersome for them. So whilst they have a process that's coherent and it's run as a whole, the data is not. It's spread across a number of installations. Many times they can have more SCADA systems, and they can have different vendors, different versions of the same systems. They can have the data in different formats, CSV or proprietary formats. And in addition to that, the data can also be updated in different time frequencies, like in real time, seconds, minutes, hours, or even on a 24-hour feed. And it's pretty much always mixed. You don't get it all in second or minute format. And what we do from in terms of data collection is we don't form a data lake. We connect or read directly from the source systems, which is reducing the amount of investments for the customers. Also only doing read. We don't have to have write access to that. And we also have off-the-shelf adapters to connect to these typical systems which you see out in the industry. And we also launder the system or wrangle the data so you have it in one format, which makes it much easier for the customer to look at it in a coherent way. Once you have this, the next thing is if you want to take the customer from getting access to the data and optimize and control it, you need to help them free up the time. And in this particular industry, reporting is the one big issue for them. The reporting has been increasing over time, and here's one example from Spahr where they're demonstrating the data. Having access to the data is really easy for them to visualize and demonstrate what they're actually doing and producing in terms of biogas and flow and different types of nitrogen and phosphor, etc. The problems when we meet the customers, when we come to them, is that creating these reports is either it's within the production department. The alternative they're working with when we meet them is it's a time-consuming manual way. It's very resource intense, and every report is more or less a project. And they export them in different Excel formats and try to blend them together. The benefits, of course, is this is a flexible approach, a short decision path, and they can typically manage within their own department. In some cases, they take the approach of involving IT, and well, by definition, you get an IT project, and many times it's an integration project, which in turn increase IT infrastructure costs. You'll have tools that require specialists or either as consultants or training of your own staff. Of course, the benefits there are you have structure and control, but you are dependent on having these new type of specialists. And in some cases, as we're talking a lot about reports, which being one of the parts here, the financial departments typically have some reporting engine or business intelligence system. And again, they're typically built around you having a specialist or writing requirement specification for someone to implement your particular report. They're not operational tools for a process engineer or production engineer or what have you in your production organization. But saying that, I mean, they're built for purpose as a reporting tool. They'll give you a control and they really look good. But the question then is, how big a problem is reporting? Well, for this line of business, that was one of the keys, or is one of the keys for them right now. They're having to produce governmental reports, production reports, management reports, KPIs, etc. And these are, of course, with the different coming either it's every week or month or quarter or year. It consumes a lot of time, and it typically consumes a lot of time from the specialists who are the ones you want to be working on your optimization and automation tasks. So once you have the data, and up here to the right, you have a screenshot of some visualization from the tools. And this would probably be a view which one of the process engineers would prefer to look at. Once you have the data in there, you can start to work with the data, and you free up time from writing reports and creating data for external factors. You can analyze deviations. And to the right, you see an example from the yellow marked part there is a pump that failed. And doing some analytics and working with deviations, we can conclude that we could have detected that 21 days in advance, creating an early warning. Doing that and also creating soft sensors in the system or using it for dimension analysis, all these factors can either enhance your process or save costs in terms of CapEx in analyzing how much capacity you need. There's an example below in Swedish where one of our customers is talking about how they in a matter of minutes concluded that one of their pump stations was over-dimensioned. Moving on from there, I mean, once you freed up the resourcing and start working on automation and machine learning, you can either do it, of course, rule-based with soft sensors. And what we mean by soft sensors is combining different types of sensors you have in your infrastructure or process and coupling them with either calculations or combining them with thresholds and etc. Or also, as you're now working actively with the data, you can apply machine learning, which we've implemented in our tool. So making it easy for the process engineers or whoever is actually working with the different models. And some of the effects then from doing this, freeing up the resourcing, getting access, tapping into the value of your data. I mentioned earlier, one of our challenges working with our customers, wanting them to look into the optimization and automation parts, they needed to free up resources. And these are, in this case, from one of our customers, they were spending a lot of time with different types of reports. And by using our tool, they were able to free up a lot of time, moving from 746 hours per year down to 50. So saving more than 90% on average on creating these reports. And the type of persons you're using for those types of reports are typically the ones you want to use in your development projects. And they had also done this comparison in terms of they were spending annually 200 hours grabbing data to see, okay, we're going to do this development project and what is the statistics we have right now. And that they could free up down to 0. So again, we could free up capacity and so on. And the real interesting part is they could compare over a 10-year period, the first 5 years they were doing without our tools, and from there on they started to use our tools. And with the free up resources, they were able to speed up the optimization efforts. So going from a rate of 1 to 1.5 million SEK per year in terms of optimizations of the processes, they were able to double that. So the efficiency gains by solving these, tapping into the data, having access to it and optimizing it, managed to not only save time, but they also managed to free up their resources and make additional gains. And that's the big value here for them in terms of not only the direct parts. And the reasons here, so why do you need a curve, etc.? I was showing you the pyramid from the start. So I mean, there's a lot of systems out there that are working with. The benefits we see is, of course, installation, getting started. Typically, these SCADA system, for example, it's months or not to say years to install. We're doing our installations in days. We're tapping into the existing data streams they already have and help them tap into the value. Training, our users typically start with less than a day's training, and then we'll provide them with the repeated training. And the user experience, of course, important for them, is easy to get going. The type of people we're addressing or production, they're not the typical ones looking into BI tools or advanced integration platforms. They're used to Excel, they want a speedy, understandable part to work with. And then getting the efficiency gains in terms of whether it's reporting, but not to say the least, optimizations of the processes, and enhancing that is, of course, an important part. You want a good combination here, which we'll manage to achieve. The next part, we're working with a business model which is software as a service. Both have it as a cloud, but and for safety reasons, security reasons, it's often installed on site with our customers. We have it to be a standard way of working with our customers, helping them through this, because we know the challenges they're working with. We know how to deal with them, and we have a set of specialists both on IT in terms of the process and subject matter experts to help them through these steps and get them to production enhancements. And we do that from a meeting, doing workshops, installations, getting up to speed and starting to get these values. So I think that was within the 10-minute mark, I hope.
Not really, but it was okay, Gustav. So it's 11 minutes, that's fine. So we have time for questions, if there are any. I got one about how are you funded?
We're privately
financed.
funded.
Let's put it financed. Let's put it the right word. Yeah.
We're self-financed presently, so we're growing with our customers, but we're of course looking into, and that's something we could have discussion, but that will be our CEO, Jonas Beckman, will be the point of contact for that.
Any other questions? And I know for sure that you are based on things in our office hotel, which is great. So we know you a lot. So it's easy to meet you. Just come and say hello. Thanks. I think we stop there because I don't receive any other questions. Thank you so much, Gustav.
Thanks.
Please and share your screen, please. And we will jump into our next speaker, Mr. Pär Bergsten from H&D Wireless. Are you there, Pär?
Yes, can you hear me?
Loud and clear.
Almost sounds like Melody Festivalen.
Yeah, it is.
So can you see my
Absolutely.
Digital transformation of your business process. So, so we get started then.
Yes, please take it away.
So we are an old Internet of Things company. You can say I started this company in 2009, and we have shipped over 1 million of wireless devices. So we're coming from the connectivity side. Me myself was 14 years with Ericsson before, so we are very good in wireless connectivity. But on top of that, we have built a platform analyzing the company's physical assets and processes, and trying to get out the KPIs from their processes and present and visualize and analyze. And we got a lot of prizes, and we're listed on NASDAQ. So one of our focuses here is to put the data in the hand of the people that are working on the factory floor and that really need to have a better overview. So we are collecting the data via our infrastructure, and then analyzing and presenting the data in the hand of people working there. So in mobile phone apps or screens in the truck drivers, forklift drivers cabin there. And we, on top of the connectivity, we have added positioning. So we are using indoor positioning and outdoor positioning, quite state-of-the-art technologies. But we don't sell technology as such. We sell the data. We provide a service, again, the data of the customer's own process. So I will give more examples on that, but see if I can get a live video here. This is actually our only forklift, but we have one of our own. So here we are illustrating our GEPS, Griffin Enterprise Positioning Services, and particularly the production logistics, focusing on the material flow. Here you can see there is a forklift driving. He has material, and we are showing the material and actually the transport that is loaded on the map. But we think that the map is one way of viewing this, that the other way is the dashboards with the KPIs that you can see on the right side. Here you can see the driver drove into something, he crashed, and we are then alerting that, so he can then check the cargo if something maybe was damaged, so he has to replace it before it comes to the next place in the assembly. So production logistics is where we look at the material. Asset management is when we look at the assets, and one of the important assets is the pallet, and even just empty pallets, because empty pallets are very expensive if you don't have them when you need to have them. So that's why we are able to track them and count them and show where they are. And here you can see we are increasing the stock, the inventory of the empty pallets. The final thing is we of course also are tracking KPIs for the vehicle itself. So it has a different symbol, of course. And again, it's not the key thing is not the map by itself, but the data we're collecting from this. Of course, if you only have one, then it's a little bit difficult to talk about utilization of the whole fleet here. But this is just in our own factory, showing how the system works. I will jump a little bit because we are a bit squeezed in time. Here, the forklift is coming and placing the material, and then it will become available again. So the fourth service that we have built on top of the platform is safety, because since we now have a system that is able to follow material forklifts, pallets. We can also follow people. And here you can see we are following the person moving here in the factory floor, and he is now coming into a dangerous area, and then we're getting an alert. So that's our fourth service. That is important for factories, but we also think it's a lot of different areas. We see a big need within the construction industry. But most of the time and money we have invested over the last 3 years here, we have been working with big industry companies. So we have then looked at the material flow coming from the suppliers, and they often have what they call RTPs, that is transfer packages moving back and forth. So again, when they are offloaded, they are empty and they need to get back, otherwise this flow stops, and then the whole material stops with known results. I think this is a very live example here. We're calling that flow the external logistics. We have projects in there. What we have worked with mostly within the last 3 years is the internal RTP between the stock inside and up until the assembly stations. So that is very often called production logistics. So that part we have installed in several of the big factories and is running. So I have some examples of that. Last year we also acquired a company here on the West Coast called MVV. We then got the small software called Casat. It's a manufacturing execution system. So we actually have a software now that can also monitor and give digital instructions to the assembly part of this. So that's a complement. And why am I talking so much about the material? Well, if you see here, this is an example from Volvo's annual report 2017, where you can see the material is the biggest cost, definitely comparing with anything. So the people cost is much lower. Because the whole industry in Sweden is already very much automated. So, but the flow of the material, that is not very automated. That's very manual. So that is a gap here in the whole production that we have seen, and that's what we are focusing on. And we have started here, as I can see some of our colleagues here is looking at. Of course, we're starting with digitize and then visualize and then understanding more. And then we have started optimizing, and the goal is to come to automation. That's the final goal. And we're already working with some parts there. Cannot talk so much about that. But we are sort of in the middle of this. Analyze is what we're supplying. The goal is automation. I will not show all the details here, but a few examples. One of our customers is actually not in the industry, but they are very stressed right now as well. They are trying to transport a lot of people with having too few drivers right now here in Stockholm. And when they're not running with the buses, they park them in their depots. And in their depots, they so far have been walking around with a paper and writing down where they are placed. And every time that guy have been out finding out where the buses are and goes in, well, then it's wrong again. So our system is helping them very much now to make the depot more efficient. Scania Smart Factory. Scania is one of our customers that are happy that we are press announcing that we're working with them. We are even able to bring in customers to Scania Smart Factory. So if you're interested, we can set up a private show there if you just give us a call. We have had several companies there, like ABB, GE Healthcare, and so on. Here we can demonstrate the basic features, but I will not show everything. But here are some happy guys at Smart Factory. The guys are responsible for the Smart Factory. So we have installed our solution there, and it's also communicating over 5G. So that's what I can show right now.
Excellent. You were actually 4 seconds after 10 minutes, so that's brilliant, Pär. So I already have a good question for you, one I know you love to answer. So the tracking is based on some kind of text. What is the tracking technology? Do you store some process information into the tags?
We are actually very much using many different technologies. Depends on which part of the flow. Fundamentally, we're using ultra wideband, which is an RF technology where you're measuring time over air, how long time it takes for the radio signal to transfer over the air. But we're also using cameras. We have our own technology with edge AI, analyzing the different objects and connecting that with the radio positioning. We are also using simpler things like BLE in some places where it's not that necessary to have the accuracy. We are using ultrasonic, Wi-Fi, GPS outdoor, and cameras outdoor, BLE outdoor. So there's a lot of different technologies that we combining and making use of, like we have it on the shelf. So when we start to talk with the customer, they start to ask about, oh yeah, well, is it BLE or is it LoRa or what is it? Then we try to move the discussion over to what is your flow? How does your process work? How many units do you have in your flow? How do you transport it? What are your key indicators? What would you like to know more? And then we start to have a good discussion on and can model it, and then start to implement and analyze and provide the data so they can optimize themselves and eventually automate.
So the second part of that question, I guess I understand the answer to, do you store some process information into the tags themselves?
Fundamentally, we are using the tag identity just as the identity, and then of course sending up health data of what is the health of the object it's following. So using the ID, we also have NFC in it, so it's easy installation. And then we have sort of a digital twin of the data in our server. But we can store a lot of data. We can store sample data during a longer transport when it's not being connected. We can store for well, we have 2 megabyte storage there.
I have a new question for you. Is it similar to TensorFlow, a video-based system?
I can't comment because I haven't compared with that. But we use a lot of standard technologies, but we also have very good engineers. And again, we look at the flow, and then we select the technology depending on the cost and time to implement and so on.
Brilliant. You got a good thank you for your answers, Pär. So having worked for many, many years with you, I know that you know this inside out. So thank you so much. And please share your screen, Pär, so we can jump on to our next and final speaker, which is Linn Sidahl from Ekkono.
Hello.
Hello, Linn. How are you doing?
I'm good. I hope everyone else is good too. Last one.
I'm amazed. Everybody's actually here except one, which is amazing. So it's up to you to entertain them for a couple. Yeah.
Yeah. And now I have a video on, and I will also try to share my screen. So can you see my screen now?
Perfect. Yes, it's okay.
Good.
So tell us what the background behind you is.
Yeah, that's Varberg, where Ekkono is from, and there are some of my colleagues going down to surf. It's from last summer when we had a kickoff with a lot of new employees.
Okay.
So
Great.
I'm Linn. I work at Ekkono as head of business development. We are a software company based in Varberg at the west coast. We also have an office in Borås at the University of Borås. And simple reason behind that is that our CTO, who's also co-founder of Ekkono, he is the researcher behind our technology. So he's setting up our R&D team in Borås together with all of our data scientists and machine learning engineers. And then we also have an office in Gothenburg at Volvo Camp X. So that's Volvo's innovation hub, you can say. And I'm there 50% of the time, and I'm in Varberg 50% of the time. And right now I'm in Varberg, of course, working from home as everyone else. So Ekkono, we do machine learning for IoT. And what does that mean? It simply means that we do edge machine learning. And at Ekkono, we never say edge or cloud. I really want to emphasize that. We see this as a pure complement to cloud in those cases where edge is a better option, more or less. And why would edge be a better option than cloud? Some reasons that we typically bring up at Ekkono. First, that comes to mind, I think, to most of us is data volume, of course. Transferring raw data from sensors to cloud when 50+ billion units gets connected, it will not be feasible in the future. So that by that we say that we need to move some of the intelligence to edge instead. And second is when you analyze or when you do machine learning in cloud, the typical thing is that you use some kind of average of the sensor data that you send to cloud, and then you run your machine learning, and then you send down the result or an algorithm. So when you instead move the machine learning to run on board a connected device, you can use all the data from sensors. So you use all data in real time. And by that, you will have no latency in your machine learning. And of course, a connectivity issue is resolved if you run your machine learning directly on board. However, as I was saying before, we make connected things smart. So we actually haven't seen a lot of use cases with our customers, at least, where the devices aren't connected. And data integrity is actually something that our customers has learned us about. And that is that it might not be feasible in the future to transfer sensor data that would tell, for example, user patterns. You could say one example is that you might not be able to use raw data of how fast the car is driven and a GPS position. But a way of getting around it, or a way of handling that issue, is to make the data into results or smart algorithms. By that, you actually anonymize it in some sense. So that's also an area where edge machine learning comes in. And of course, most importantly, what Ekkono is always talking about is that if you move your intelligence to be on board your connected device, you can also learn individually for each device. So your machine learning model could adapt to the external factors or the external conditions that's around your connected device. For example, a car or an automower or whatever. Core of Ekkono is that we do something called incremental learning, which is that we update the model as new data comes in. And we can do this on edge. And that's the result of the research behind it as well. And one example here that you can use is if we go back to the car, for example, and you would like to estimate how far you have left to drive on an electric car. You would like to take external factors such as the temperature around the car, the road conditions, how it's driven, etc., and put that into your model to get a more accurate estimate. And you could do that with incremental learning on edge, and rather than having a general model for all electric cars that are driven everywhere from Madrid to Kiruna in Sweden. So it's a way of adapting the model to changing situations, and also to make it more accurate for each individual condition. Use cases. What can you use this for? Well, what we see is that edge machine learning enables individual learning and optimization for a lot of different use cases. And we typically see this as a stair where we work with the first 3 steps, which enables the last step. So if we talk about current, for example, you can use machine learning to get health indicators of the status of a machine, or you can use it to produce new values, which we call virtual sensors. Predictive is usually predictive maintenance. You would like to predict when something is about to fail. We do this by learning the normal state and then detect deviations. Another way of doing it is to collect historical data of thousands of units that are already broken down. We believe that this data is almost never available. So what you could do is learning the normal state and then you detect the small deviations on edge. And prescriptive, this is performance optimization and self-installation. And this is where connected things can take in sensor values from the external conditions and be intuitive and self-learning to optimize based on that. And this leads to the final step, which is cognitive, and there's where we see autonomous vehicle, etc. Ekkono is not working with autonomous vehicle, but we are one part of the puzzle, and that's what we want to show with this picture. And possibilities. Well, first, of course, you get intuitive products. If products can use sensor data and can understand their environment and self-adapt, they will be more intuitive. So it's not about connecting stupid things anymore. It's actually about connecting smart things, which we believe is much better. And the data-driven business models. And I think this is really interesting. And one of the things that we talk a lot about with our customers is how can you leverage with new business model with new technology. And one technology is, of course, edge machine learning. So for example, could you upload learning from old to new products? Could you upload models from service schemes, etc.? What do we do? It's abstract, of course. We sell code. We are a pure software company. And the business model is to sell licenses, essentially. It's made by developers for developers. It's platform agnostic, so it doesn't depend on any specific platform, and we support multiple machine learning techniques. And the thing here is that our customers are able to harmonize on one tool for edge machine learning. So this is a tool that our customers use to develop their own solutions around edge machine learning. And why are we unique? Well, it's built for purpose, so it's built for running on edge, unlike open source solutions that are usually not built to run on edge. We have unique features like incremental learning that I've been talking about. And as I said before, this is just one part of the puzzle of an IoT ecosystem. But we believe that it's a good start of getting out the true potential of the IoT at least. And it's one tool to develop all edge machine learning solutions that you'd like on your products. Where do we deploy it? We have customers in the whole range from industrial to consumer IoT. We work a lot with automotive and industrial automation at the moment, but we see increased traction in the other industries as well. And as I said, we are a pure software company. We sell licenses. That means that we need to work with integration partners to build the actual application around Ekkono, because Ekkono is just an embedded software. You need to build an application around it in order to actually leverage from the possibilities. And there's where Cybercom and Orange and Amazon comes in, for example. And I would like to stop there because I think I'm just under 10 minutes now. Just open for questions.
No, well, you are doing very well. You're actually 8.5 minutes into it, or 9. So that's fine. Let's stop there. Thank you. We have a question here from somebody who says, how are you financed?
We have external financing. So we have Valrud Ventures was the first investor in us. And then we have another family office called Lindeblad Ventures and Alm Invest.
Okay, great. Another question here comes, could you, well, maybe it's not fair, but could you explain the major differences between Ekkono's offering and Imagimob's offering?
Well, my very diplomatic answer is that I'm not familiar enough with Imagimob's solution to compare.
Okay, well, that's probably a good answer. As I feel like a TV person right now, so I said there are all kind of other solutions available as well.
Yes.
So no, I don't think we should do that. So
No.
let's leave that. Any more questions from the audience? I don't think so. So let's put it this way, talking about Ekkono and Imagimob, since I'm not involved in any of those companies, but I think these two companies were the first ones, at least around here in Sweden, who really addressed the edge approach to machine learning. And they've done it very well, and they've done it in different markets and segments and so forth. But they have learned a lot during the years, so to speak. And we work a lot with Imagimob as well. So next time maybe they show up. So thank you so much, Linn. And you can please unshare your screen.
Yes.
And with that, my friends, I'm amazed that we still have everyone but 3 or 2 attendees. I hope you enjoyed yourself. I must tell, I'm proud like a father that we have those spectacular members of things, spectacular entrepreneurs doing all those things. And I hope you were impressed by what you heard. And I really, really, really hope a lot of this will be continuously discussed between the 2 of you who are interested in. We will send you the contact details for all the presenters, and if you like, you can provide comments and feedbacks on the chat, because we're going to save that, and you can also provide feedback and comments and proposals in mails afterwards if you like. So with all of that, thank you so much. We are really happy to have made the first kind of live show with eBazaar. And I'm probably more happy than all my colleagues, because I get nervous like if I was running CNN or something like this. Thanks a lot, and have a very nice evening. Bye-bye.